In this lecture, I'm going to taught you about Lucas theorem and where we can use it. Okay, so let's take a simple example. Uh, then we will tell you how what is Lucas theorem and how Lucas theorem solve this problem. Okay, so you have a n c I value modulo something m modulo p. Okay, so in this lecture, our modulus is going to be prime number. Okay, modulus value is prime number. In the next lecture, next lecture, I will taught you about for the non-prime number or composite number. Okay, so let's see n is order of 10 to the power 18. Okay, and I is order of also 10 to the power 18, and value of p is order of 10 to the power 6. Okay, so how you can solve calculate the value of this NCR modulo P expression? It is going to be very costly because value of N and R is very large, and value of generally in the problem it is given that like if the N and R value is very large, then value of P generally given as small, not much large, but it can be prime number or it can be non-prime. So in this lecture, I am going to taught you about prime if P is prime, and in the another lecture, I will taught you about if P is composite number. Okay. So Lucas theorem give you a simple expression. The value of n c r modulo P going to be equal to multiplication of n I c r I modulo P. Okay. And you can also apply whole modulo here on the after multiplication as well. Okay, so that is the simple expression given by Lucas theorem. Okay, let me round it. Okay, so that is the expression of Lucas theorem if p is the prime number. One more condition here that if ni is less than ii, then in that case your value of NICII is going to be 0. Okay, and that means your whole multiplication becomes 0 and value of NCI modulo P is also equal to 0. Okay, so let's see what is this NI and RI. Okay, so NI and RI is nothing but it is N equal to NGO plus, let here I start with 0 to something like it goes till infinite, but later on your value of ni and ii becomes 0, so your modulus operation value become 1, and it doesn't affect your multiplication, so you have to stop somewhere. Okay, 1 and 1 into p to the power 1 plus n2 into p to the power 2 plus n3 into p to the power 3 up to infinite. Okay, similarly your r should be and sorry, let's erase this one. Okay, r0 plus r1 p1. Okay, plus r2 p2. Okay, plus r3 p3 to infinite. Okay, So uh, after some time, your Ni and Ri together become 0, and your NCR expression become 1, and it doesn't affect answer. So y- it is not much infinite, like uh, it is stopped somewhere. Okay, so let's take a simple example. So we have already got it where we can use this expression. If n and I value is very large and your p is small, but p should not be much large. If p become large, then still your computation become heavy, because value of ni and ii is in order of p. Okay, let's write here ni or ii between the value of ni and ii is between 0 to p minus 1. So let's take a worst case scenario when value of ni and ii is p minus 1. In that case, your computation has complexity of O of n, okay, and it is O of p, and p is also very large, so you still cannot calculate the value of final NCR. Okay, so you have to for using this expression, you have to has to be p should be doesn't be much large. It it would be better if it is order of 10 to the power 6, or at max 10 to the power 7. Okay, so let first analyze the complexity of calculating this NCR. So if you calculate direct NCR directly, then it is order of O of n. You have to just pre-compute the factorial modulo m. Okay, but what happened here? Here you have to factorize your n and I. It is going to be O of log of n. Okay, you can take base p. Okay, multiply by O of wha- O of ni and ri. And what is that? It is in order of p. Okay, so you can write here simply p. So you can see here using Lucas theorem, you can reduce the complexity of the calculation from O of n to O of p log n. Okay, so let's take a simple example. Okay, uh, let calculate value of 9c2 modulo 3. Okay, so what is going to be the value of 9 to c modulo 3? It is going to be 9 multiplied by 8 divided by 2. Okay, and it is 36. Okay, modulo 3, and it is, let's calculate this using Lucas theorem. So we can write 9 is equal to 2 to the power 3 multiplied by 1 plus 2 to the power 2 multiplied by 0 plus 1. Okay, similarly we can write 2 as a 2 to the power 3 multiplied by 0 plus 2 to the power 2 multiplied by 0 plus 2 to the power 1 here, sorry, 2 to the power 1 multiplied by 0 plus 2 to the power 0 multiplied by 1. Okay, 1 multiplied by 1 plus 2 to the power 0 multiplied by 0. Like coefficient of 2 to the power 4 here also 0, and coefficient of 2 to the power 4 here also 0. So it doesn't make sense to go for 2 to the power 4, 2 to the power 5, and it is value, it is a p. Okay, 2 is p is equal to, sorry, let's take here 2. Okay, I will give you another example. Okay, uh, 36 modulo 2 is still 0. Okay, So let's see here, value of 1c, 1c 0 multiply by 0c 0 multiply by 0c1 multiply by 1c0. Okay, so what is going to be value of this? It is going to be 1 multiply by 1 multiply by 0. I have already told you one condition here. If n is less than ri, then in that case value of nci is 0. Okay, so here ni is less than ri, so value of nci is 0. Here 1c0 is equal to 1. So final value is 0 modulo 3, 0 sorry 2, which is equal to 0. Okay, so here you can see that using direct computation we got 0, and using Lucas theorem method we also got 0. Now let's take another example. This time I will take some uh, where it is not going to be 0. Okay, so let's take 12c 3. Okay, modulo 3. Okay, so what is going to be value of this expression using direct computation? 12 multiplied by 11 multiplied by 10 divided by 1 2 3. Okay, and what is the value? This cut down with this left with 2. Okay, and it is going to be 220. And what if we apply modulo 3, then it is mm, 1, sorry, 119. 119 is not divisible by 3. 118, yeah, it is 1. Okay, remainder left with 1. Now let's compute this using Lucas theorem. So how we can write 12 in help of 3, which is p. Okay, so we can write 3 to the power 2 multiply by 1 plus 3 to the power 1 multiply by 1 plus 3 to the power 0 multiply by 0. Okay, and how we can write 3 here? 3 to the power 0 multiply by 0 plus 3 to the power 1 multiply by 1 plus 3 to the power 0 multiply by 0. Okay, so what is the coefficient? 1 0 here, 1 1 here, and 0 0 here. So let's write expression 1 c 0 multiply by 1 c 1 multiply by 0 c 0. Okay, value of this going to be 1 multiply by 1 multiply by 1, which is 1, and 1 modulo 3 is 1. So here we can see where using the Lucas theorem we get 1, and using direct computation we got 1. Okay, so that is all about Lucas theorem. If p is prime, again remember, p is going to be prime number. It is not equal to, it is approximately in order of 10 to the power 6. Okay, so this is all about Lucas theorem. Thank you for the watching.